previous tutorial, part 1 of Procedural Cities Generation, I showed you how to create this cityscape using Perlin Noise and a variety of different buildings to set different architectural zones within the city itself. So this is the city that we generated at the end of the last tutorial, but I've also cut it back to be 100 by 100 rather than 200. As I said at the beginning of the last tutorial, that it's probably best that you just work with a small sized city to get things right and working before you start generating massive cityscapes. Oops. Okay, so what we're going to do now is actually put some roads into the city. And we're going to do that using a very simple method of just creating a city grid system across the map. So what I've done to build these roads is, first of all, I've gone to the asset store and I've grabbed hold of this really great little kit that I found called Simple Modular Street Kit, which has a whole heap of different roads in it that you could use. Now, we're only going to be using the straight ones and the crossroads to generate our grid system. So grab hold of that package and download it into your project. From that package, we're going to need to create our streets from some prefabs. Now, first of all, we need, if you go into the streets folder, you'll find there's a cross T. If I bring that out into here, you'll find you've got that, okay? So we will create a prefab out of that cross system just by grabbing hold of it from the hierarchy, and we will put it into just the assets at the top level. And then we also need a straight piece of road. Okay, so this street lane 30, if I bring that in, you'll see how big it is, will do us. Okay, so we will use that, and I'm going to grab hold of that and make a prefab out of it, put that into the assets. Now we also need the same street but going at 90 degrees. So if I just duplicate that particular street and then rotate it by 90 degrees around its y-axis, we now have our other street that goes in the other direction. And I'll just put that into the assets as well. So in the high level of assets, we now have our crossroad prefab, we have our street lane prefab, which has no particular rotation applied to it other than its default one. And then we have the other one that we created. So let's just create from these new names for this street. I'll call this street Z. So it's running along the Z axis. And the other one, let's call that street X, so that we know it's going in the X direction. Right, so at this point we can then delete the objects out of the hierarchy for those streets. Now, just skipping ahead a little bit, if you use those prefabs for the streets at the default sizes that they come, I'm just going to run this and show you what happens. This is the final version of the code, but you can see that those streets, they're just way too big for the map. So to make them fit better, you need to scale them down. Now, with these particular streets, the cross X, we want to scale that down to 0.1 in the X and 0.1 in the Y. That crossroad is actually built in the XY plane for some reason. I don't know why, but it is. And once you start mucking around with these values, you'll notice that. But for the X street and the the Z street, they're both 0.1 in the X and 0.1 in the Z. And if I just change both of these and quickly run the final version of the code of where we're heading, you'll see that they look a lot better. Okay, see how they fit a lot better and they look nicer. So if you get a complete mess when you go to run your code, make sure that you check that your building sizes and your other objects, the streets and everything, are the actual right size that you're working with, that they're all sort of relative to each other. And you can do that by just dragging the prefabs into the scene and placing them all next to each other just to check. Right, so back to the business of getting this code written. Now, to use Perlin Noise to generate our grid of streets is, well, it's not impossible, but let's just say it's probably a little bit too difficult and an overkill of what we're trying to do. So we're going to use a grid system to build our streets, and therefore we're not even going to use the Perlin Noise for the streets. We're just going to use it for the building architecture. So with all of that still the same as before, in order to create our streets, we're going to use a grid, or we're going to take advantage of the grid that we've already been generating. But now what we need to do is save the grid with all of the building values from the Perlin Noise into a two-dimensional array, and then input the values for the streets over the top before we actually draw anything. So I just have an image I'll call up to illustrate what's going on. So this top matrix here, let's say that this is our current map, and these are all the values generated by Perlin Noise, which determine which building goes in which spot. And there's no allowances for roads whatsoever. So the roads essentially are going to plow through this array. Now, this bottom example that I've got here, I've put some roads in. So what we're going to do is to randomly pick a position in this array and just draw a road straight across the entire array. So anywhere where we've got a -1 value that we're inserting into this array is going to be a road that's going in this direction. And you can see I've put another road in this direction here. So to begin with, we'll go through and put roads in one direction throughout the whole array. Then we'll come back and we'll do it again, but we'll go in the other direction. And you can see I've put -2 for this particular road here that goes through. Now, anywhere that the second road crosses the first road, we're going to put a -3, and the -3 will represent the crossroads, so that we will get the road that faces in this direction, the road that faces in this direction, and then the X crossroads, which joins it all together. Right, so how do we achieve that? Let's go back and have a look at the code, which has now changed quite dramatically. If I open this up and go to the top so you can see what has changed. First of all, I've got some public game objects. I've got the street for the X direction, the streets for the Z direction, and the crossroads streets. Now, these are the prefabs that we created just before. I've still got our map width and height, okay, which is being overwritten in the inspector where I've got 100, 100. Then I've included this map grid. So this is our two-dimensional array being declared, which is going to store all of the values for what is in our city at any particular location. So they're the new objects in here. Now, inside the start function, we're adding map grid and initializing it to be a two-dimensional array, the size of the width of the map by the height of the map to store all of our values. Now we go ahead and we generate our map data as we did before, but instead of drawing the buildings or instantiating them at each position, we're going to store the Perlin Noise value into the map grid array at that particular WH position. So instead of drawing, we're saving it into memory, basically. So then we can add the streets. Now, the next part here, we're building a street in one direction across the map. So we're going to select a particular X position of the map, and then inside here we're going to loop through for the entire height of the map. So we're basically picking a position on the map and then just drawing the street straight across from one side to the other in one direction. And we're doing this 50 times, as you can see here. So this is just an array that builds 50 streets, or up to 50 streets, I should say. So that determines how many times we're going to do this particular process of building a street across the map. Now, before we build the next street, we actually change the X value by increasing it by a small amount, which will say how big our blocks are and where the next street is going to occur relative to the previous street that was drawn. And then if x at some points becomes greater than the width of the map, we've obviously drawn enough streets, we've run out of map to draw them in, and therefore we're going to break out of the for loop. Now, once we've built these streets, we then come back down here into the original nested for loop that we had, which is going to, instead of using Perlin Noise, use the values inside of the map grid for the result in this case, generate the position as we did before, and then it's going to test for the value that's stored in that array. So if it's -2, then we're going to instantiate a crossroads. If it's -1, we're going to instantiate an X direction street. And if it's, if it's less than -1, not if it is -1, same here, it's going to be actually -3 where it draws a crossroads, -2 where it draws an X street, and it'll be -1 where it draws the Z street. Why I say less than and not actually equals to is just by habit of ensuring that you pick up the right value, because sometimes strange things happen when you try and make a value equal perfectly another value, even though it shouldn't in this case because we're using integers, but this is just the way I do it. You can put equals to and have the specific values in here if you like. Now, one other thing I need to say about this instantiate is you'll notice for the rotation of the road itself, we're using the prefabs set rotation. So if you remember with the X direction street, we actually rotated it, the prefab, before we created it, and therefore we want it to keep its rotation that we set. If we use the identity rotation, it will set it back to its 0 rotation position, and everything will face in the same direction. So in the case that you actually take a prefab and rotate it and you want it to always face that position, then you would use its transform rotation instead of the identity matrix to set the original rotation of the object. All right, so this is currently going to draw streets in one direction across the map, and it's setting them to be 3 apart, and I'll just explain this in a moment after I show you what happens. So let's save this and go back to Unity and run it. Right, so here's our city, and here's all of those streets being drawn across that map, and you can see that they're all at standard intervals, which is quite nice if you're building a city. Usually you'll have like a city block where you've got 2 lots of houses that are back to back and they have streets on the front sides in this case. And so all of these are equal distances. The distances these streets are apart is based on that random range. If we go back into the code, change the random range on your X, you could have it like that they're between 2 and 10 apart randomly. Save that and then run it, and you'll see you get a very different result where you have a much larger block of houses that essentially have no access, at least by road. I guess it depends on what you're after when you're building your city, but I like to have it 2 apart so that you have back-to-back houses. And then any of the other cross streets that you have going across, they can be further apart. I guess I'm just thinking of the practicality of the people who live here and how they're going to get into their houses, and whether it looks realistic or not. Okay, so now we're going to add the code to put in those cross streets. So after finishing the streets in one direction, before we generate the city itself, we're going to put the code in here that will loop through our grid and set up the streets going in the other direction. Now, while I'm just thinking about it, I'm going to set the distance of my X streets back to a consistent 3 apart, just for consistency here and to make those blocks look more realistic. And okay, so we've got the same kind of setup for the streets that go in the other direction. It's the same array. Instead of cycling through the height, we're cycling through the width of the map. I've got a leftover debug line there, which I'll just delete because you don't need that. Okay, and now what we're doing is we're putting in values of -2 for our streets that are going in the other direction. But before we stick a -2 into our map grid, we're going to test for its value. So if the map grid equals -1, then we must be crossing over a previous road that we put in up here. So in that case, instead of replacing that with a -2, which is a road going in the other direction, we're actually going to put a -3, which represents our crossroad tile, and put that there. Now, if there's nothing in that grid point, if there's not a road in that grid point, because there actually might be a building, then we put in a -2. So by replacing the values in our map grid with -1, -2, and -3, we're putting roads in there and actually getting rid of any particular buildings that might be in those positions. And then you can see we're going to increase our step along the map for our next road that we're going to put in. And in this case, the range is quite large, so it's going to be between 2 and 20. 2 is probably giving you very close rows. I'm going to set that to 5. These are sort of like the block sizes in the other direction. And then again, we test if our Z value has reached the height of the map, then we're obviously finished. Okay, so let's save that. And let's go back into here and run it. Okay, and you can see that we now have a nice grid system going on in the city, with nice park areas surrounded by roads. And if you come down closer, you can see that where every intersection occurs, it's putting that tile in automatically for you. And you can play around with the sizes of the different blocks, the distance that the roads are apart. So you can see the roads going in the other direction. They're quite far apart. They're not 2 or 3 apart like the other ones going the other way. And then, you put some cars in and have a bit of a play around with the city. You might even test if you have a grassy area and put trees in that particular position. There's all sorts of things you can do with the code to generate different buildings and different situations within there. So this is basically a very, very simple city with grid streets in it. There's other more advanced techniques that you can use for producing procedural cities, which things like City Engine actually use themselves, but they use a lot of more complex mathematics. But this is just a really simple way to get you started looking at procedural cities. So thank you for listening, and I hope you enjoyed these 2 tutorials and that they inspire you to build bigger and better maps.